Hello everyone and welcome back to What the Heck Math. Today we're going to further explore the question, what the heck are limits? So today, instead of talking about what limits are, what we're going to do is just solve some limits. So I'm going to present some problems. Feel free to pause after I show the problem to try and solve it yourself. Then start playing the video again, and then you can see if you got it right, and if you didn't get it right, hopefully you can figure out what went wrong, what you did wrong. Okay, so if you haven't already watched the videos about limits themselves, I recommend that you go back and do that so you can understand what I mean by limits and what a limit is. Okay, so first we're going to start by solving some limits that can be solved simply by using substitution. So for our first limit, so let's see here, we're going to go the limit as x approaches, let's see, minus 1/2 of this function, 3x squared times 2x minus 1. Okay, so now this is a limit that can be solved just by using substitution, which essentially just means you can take this value and just plug it in to the equation. Okay. Now for this one right here, we're looking at this equation right here. It's the limit of the whole thing, so we could put the parentheses around this if we'd like. Now we could distribute that across first, but it's possible that it might be easier not to. Okay, let's see. Let's just leave it like it is. Now, when you solve limits with substitution, the first thing you're going to do is you're going to try and take whatever you're approaching in that limit and just plug it in for x, wherever it is. Okay, so sometimes you can solve it like that, and if you can, well, that's the easiest way to do it. So let's go ahead and do that. So we're going to say 3 times minus 1/2 squared times 2 times minus 1/2 minus 1. Okay, so minus 1/2 squared, so that's going to be 1/4. So then it's 3 times 1/4. 2 times minus 1/2, that's minus 1. 3 times 1/4 is 3/4. And then minus 1 times minus 1 is minus 2. And so we're going to multiply these, so these two cancel out, so that becomes a 1, that becomes a 2, and then so our final answer ends up being minus 3/2. There's our answer. Okay, so simply we just plugged in x wherever it is and evaluate it as if it's just an algebraic expression. Simple as that. So this is basically just algebra. Okay, let's try another one. Okay, so this one we're going to go limit as x approaches minus 4, x plus 3 to the power of 2016. Okay, now this does look really ridiculous, okay? So, and using substitution, we can say, okay, well, if whatever I plug in here, it seems to mean that I'm going to have to take that and raise it to the power of 2016. So I better break out my calculator. Well, before you go grab your calculators, let's look at this. Let's just see what happens if we plug in -4. So again, we're going to be using substitution. So we're going to take this value and we're going to plug it in right there. And we're going to try and evaluate this as if it's just an algebraic expression. So that means we're going to have minus 4 plus 3 to the power of 2016. Well, minus 4 plus 3 is minus 1 to the power of 2016. Now, to solve this, all you have to do is say, okay, well, this is minus 1. So if for every power that is odd, we get minus 1. For every power that is even, we get positive 1. Well, since this is even, we get positive 1. And there's our answer. Simple as that. Okay, next one. Alright, let's see here. So we're going to go limit as x approaches 1 of x cubed plus 3x squared minus 2x minus 17. There we go. Alright, so here we have a degree 3 polynomial, but again, all we got to do is take 1, put it there, and there, and there, and then evaluate it. So we'll have 1 cubed plus 3 times 1 squared minus 2 times 1 minus 17. 1 cubed is 1. Then we have plus 3 minus 2 minus 17. So let's combine these from left to right. So let's do these two. So we get 4 minus 2 minus 17. And let's do these two, 2 minus 17. And now we can do these two. And then we get minus 15. Alright, yeah, so solving these by using substitution is very simple. And it is always going to be, especially when you're finding limits as you approach a number, it's always going to be the first thing that you do is see, okay, well, can I just plug it in? Because if you can just plug it in, well, then that's how you get your answer. Now, sometimes this is not possible. Okay, so let's look at an example. So we're going to go the limit as x approaches 1 of x minus 1 over x squared minus 1. Okay, so first let's try and solve this using substitution. So let's do it right down here. So I'm going to plug in 1, so I get 1 minus 1 divided by 1 squared minus 1. Well, 1 minus 1 is 0. 1 squared minus 1 is also 0. So here we have 0 divided by 0, which you cannot do. Okay, we can't do a divide by 0. Now, if it was 0 divided by 4 or something like that, then that'd be fine. But 0 divided by 0, you cannot do that. Now, later on in your calculus lessons, you'll learn a different way of solving this, but the method we're going to use to solve it today is we're going to solve this algebraically. Okay, let me increase this brush size for this. So we're going to solve this algebraically. And the way we're going to do that is we're going to say, okay, well, if we can't plug 1 into this equation as it is, let's see if we can rewrite this in a different way so that we can plug 1 in. And essentially what that means is, can this be simplified? Okay, well, x minus 1, there's nothing we can do to that. Okay, so that's just going to stay the way it is. There's nothing we can do to change that. But x squared minus 1, this is factorable. Okay, so this is the difference of two squares, and hopefully you remember this from algebra, but the difference of two squares states that a squared minus b squared is equal to a plus b times a minus b. So this can be factored into these two factors. So that means this can be factored using the same method. If a is x and b is 1. So then this is can be rewritten as, well, not a. We're not going to do a anymore. We're doing x. Okay. So we've got x minus 1 times x plus 1. Alright, so now you can see that we things have changed up a bit. So now that we have x minus 1 in the numerator and the denominator, and those can be canceled out. So we're left with just the 1 in the numerator. So our simplified form is 1 over x plus 1. So that means this limit is going to be equal to the limit as x approaches 1 of 1 over x plus 1. So now let's see if we can plug that in. And if we do, we get 1 over 1 plus 1, or 1 over 2. Now, this does not mean that this function and this function are equal to each other, because they're technically not. Now, if you were to graph each of these functions, you would get very similar graphs, but they would actually be different. And the way that they would be different is, well, first of all, they're going to look exactly the same. The shape's going to be exactly the same, but the main difference is that there will be a hole where x equals 1. And so that's why the limit exists, but the function does not exist. So this is another way that you can solve these kind of limits is if you can't plug it in with substitution, try and rewrite that function so then you can plug it in with substitution. Now this is going to be a very important idea whenever you get to solving the idea of derivatives and solving derivatives using limits, because you're going to have to do this very many times. Okay, let's try a few more. Okay, so let's do limit as t, changing up the variables, approaches 2. We're going to go t squared minus 3t plus 2 all over t squared minus 4. Alright, so just like we've done before, let's try with substitution first. So if I take that 2 and I plug it into the numerator and the denominator, it doesn't really matter what the numerator is going to be equal to, because if you look at it, we plug it into this denominator and we get 2 squared minus 4. 2 squared is 4, so we get 4 minus 4, so that means our denominator is 0, which we cannot have. Alright, so now we're going to try the next step. So let's take this function and see if we can find its simplified form that possibly we might be able to actually plug 2 into. Now, in order to simplify this, typically the way that you do it is it involves some kind of factoring, but this time we have a numerator and a denominator that possibly both can be factored. So let's see if we can factor both of them. So this one right here, okay, we're going to do a little bit of algebra here. So we got to figure out how this can be factored. So let's go ahead and create our factors. So let's say we have two numbers we're going to multiply. So a here is 1, so 1 times 2. So two numbers multiplied together give you positive 2, but added together give you negative 3. Well, that's going to be minus 2 and minus 1. Now our denominator, difference of 2 squareds, so it's going to be t plus 2 and t minus 2. So we have t minus 2 in the numerator, t minus 2 in the denominator, they cancel out. So then we have t minus 1 over t plus 2. So that means this limit is equal to the limit as t approaches 2 of t minus 1 over t plus 2. Now we're going to see if we can plug it in this time. So in the numerator, we would get 2 minus 1 or 1. In the denominator, we get 2 plus 2 or 4. There is our final answer. Alright, so let's try some that are, let's try one that's a little bit trickier looking. So let's see. So limit as x approaches 0 of 1 over 2 plus x minus 1/2 over x. Alright, so let's try a substitution. Plug in 0. We get a 0 in the denominator. Can't do it. Also, we end up getting a 0 in the numerator as well, so we get 0 divided by 0. So let's see, how can we possibly make this work? Let's see here. Well, we have a numerator that is a binomial, which means 2 terms, and they're both fractions but different denominators. Now, I wonder if we combine these two fractions into one, because then, you know, whatever this fraction is, so if you have a over b over c, you can then combine this and simplify it a bit so that it's going to be a over b times c, and maybe that will change things a bit. I don't know, sometimes doing this is a little bit of a trial and error sometimes, and you just figure it out by just trying, and then you see patterns and you recognize those patterns later on, and it'll just get easier to figure out. So let's try that. It might not work, I don't know, we'll see. Okay, so we're going to combine these into one. So let's take it down here. Just the numerator. Okay, this is just the numerator. So bringing this down there. Alright. So in order to combine these into one, we have to have the same denominator. They don't share any factors or anything like that, so that basically just means we have to multiply this by 2 plus x over 2 plus x. And then this one, I'm out of room here, 2 over 2. So then we'll have 2 over 2 times 2 plus x minus 2 plus x over 2 times 2 plus x. Alright, so let's should I combine these? Yeah, let's combine the denominator, so it'll be 4 plus 2x. And yeah, okay, so we're going to do the numerator first, so 2 minus 2 plus x. And the denominator, I'm going to swap the order too, so we'll have 2x plus 4. So let's rewrite that. So we get 2 minus x over 2x plus 4. 2 minus 2, they cancel out, so then we get minus x over 2x plus 4. And that's just the numerator. So that means this is equal to minus x over 2x plus 4, there's a numerator, over x. Okay, so don't forget that this was just the numerator we're working on. And so this, we've turned this numerator into this. Now, just like I said over here, so a over b over c is equal to a over bc. So that means we can just move this denominator up into this denominator. So we get minus x over x times 2x plus 4. And now, they cancel out. Look at that. Okay. So now, ooh, I'm going to have to make some room. Okay, so we cancel these out, and then our new function is this. Okay, so let's do some erasing. Let's see, give ourselves some room. Alright, so now I can say this is equal to the limit as x approaches 0 of minus 1 over 2x plus 4. And now we can plug everything in. So if I plug in 0 into here, it makes this whole thing 0. So then we end up just getting minus 1 over 4. So again, just solved it by trying to rewrite the equation so that it can work, so we can actually solve it using substitution. Alright, let's try one more. Let's do one more. Okay, so we'll limit as x approaches 5 of x cubed minus 125 over x minus 5. Okay, so this is going to be an example of one where you might not know right off the bat if you can solve it. Okay. Now, in your math class, if you're taking a quiz or a test about these kind of problems, unless your professor or teacher is trying to trick you, more often than not, you're not going to be given a problem you can't solve. Okay. So I'm going to give you kind of a tip on how to solve one where you're not quite sure how to factor it. Because the problem is, of course, we can't plug in 5 because we get 5 minus 5 or 0. And we get 125 minus 125, so we get 0 divided by 0. So hopefully that'll help you see that there's something we have to be able to do to this to simplify it. Okay, so let's think, what is the problem? What is causing our issue so that we cannot solve this just by a substitution? Now the numerator's fine, that can be 0, that's no problem. The problem is that the denominator is equal to 0. Okay, so that means in order for us to solve this, we need to rewrite this in a way that denominator goes away, or at least is no longer equal to 0. Now, like in the problems we solved before, usually the way that worked out is that there was like a factor in the numerator that was equal to the denominator and they canceled out. Now, you may know how to factor the difference of two cubes. Okay, there is an equation that you can use to do that. You might have forgotten, right? So let's say you forgot how to factor it. Well, hopefully you know how to do division, long division with polynomials, or synthetic division with polynomials, which is even easier. Okay, so we're gonna do both here. So now the reason why I bring that up is, in order for this x minus 5 to cancel out in the numerator, it means that this must be it has to be factored to be x minus 5 times something else, and this something else is going to be something squared. Okay, so it's going to have an x squared in there somewhere. We don't know what it is. Okay, but there must be an x minus 5 in it, and so that, and if there is, we can then cancel. So this x minus 5 will be over here. These will be canceled out, and we're left with whatever this is. So we need to figure out, well, what is this thing that's going to be left over? And again, you might know how to factor this, but you might not. Now, if you know how to factor it, go right ahead, factor it. I'm going to show you what to do if you don't know how to factor it. Okay, so we basically know x minus 5 more than likely is a factor of this. Okay, so let's take this and divide by x minus 5. Let's see what happens. Okay, so let's do it with long division first. Okay, I'm going to erase this over here too. Alright, oops, dropped the book. Hopefully I have enough room. So, let's see. Alright, so just like you do long division in arithmetic, we do x minus 5, we put a denominator over here, and a numerator over here. Okay. No, and it works very similarly to long division with just numbers and arithmetic. Okay. So, but I think it helps to think about it in a different way. So, where with regular, let's see. Let's think of an example. Really simple example. All right. So if I wanted to do this, so what you would do is say, you can answer the question, how many times does 2 go into 6? And it 3 times. And then you do 3 times 2 and bring it down here. Subtract these, 0, and that's your remainder. And if it's not 0, then you just keep going, Okay, so let's try something else. Let's do 2 into 24. Okay, now hopefully you know what this is, but just to prove a point. All right, so you get, how many times does 2 go into 2? 1 time, multiply, we get 2, subtract, then you bring down the rest, then you say how many times did 2 go into 4? 2 times, multiply, 4, subtract, 0. Okay, so that's long division. Now, whenever you do this one, for me it helps not to ask the question, how many times does this go into that? Okay, because it's not going to be a number. So what I think helps is to say, alright, let's just look at the first term. This multiplied by what will give you x cubed? Not x cubed minus 1, just x cubed. X times what is x cubed? Well, x squared. Okay, so just like, I'll put it up there. Now, just like we do with regular long division, we're now going to take that and multiply. So we're going to take this x squared and multiply by this whole thing now. Okay, and so that's going to give, so x squared times x is x cubed. X squared times 5 is minus 5x squared. Oops, I said x cubed and I wrote x squared. Okay, helps if you write down the right thing. Okay, now we're going to subtract. Now, subtracting is something you need to be kind of careful of, okay? So it does help a little bit to make sure you have your terms lined up right. All right, so I'm going to rewrite what's on the inside here. So we don't have a x squared term, so I'm going to put 0x squared. We don't have an x term. And then we have our constant term. Okay, so that kind of helps. In here you can see, okay, I have a plus 0x plus 0, and I'm going to combine these. Now remember, it is subtraction that we're going to use to combine them. Okay, so you have an option here. You can either just subtract, or just find the opposite of everything and then add. And that's what I rather do, because adding is easier than subtraction. This is my opinion. Okay. So x cubed minus x cubed, that's going to be 0. Oh wait, we're adding now. But yeah, that is adding. X cubed plus minus x cubed. Okay. 0x squared plus 5x squared. 5x squared. 0. And then we'll add these. And so we have minus 125. Okay. So now, again, we're going to say, alright, this, just like we did here, okay, so we said, or how many times does this go into that? Alright, we're going to say, okay, well, this times what equals that? Well, 5x. So, plus 5x. And now multiply that by this whole thing again. Okay, so then we get 5x squared minus 25x. And then we're going to subtract, which means add that, and then we have a plus 0 over here, so that cancels out. Then we get 25x minus 125. Alright, now one more time. Okay, this times what equals that? 25. Let's multiply. So we get 25x minus 25 times minus 5, so it'd be minus 125. Then we subtract, which means this becomes a plus. We get 0 and 0. There's our remainder. So what this is saying is our original function can be rewritten as, I'm going to put that down here, x minus 5, this is the numerator, times this right here, x squared plus 5x plus 25 all over x minus 5. Okay. Now, this is a way of factoring the difference of two cubes, just like there's a difference of two squares. Now, there's also a sum of two cubes, okay? And the sum of two cubes, so if this was x cubed plus 125, the only thing that would change, and this would be a plus, and that would be a minus, okay? So it does help to just to remember it, but, you know, not everybody can remember it. I know me for a fact, I hate memorizing stuff, and it's kind of one of the things I love about math is that you don't have to memorize too much. Okay? Usually you can just figure stuff out the hard way if you have to. Alright, so now that I've gotten that figured out, this can be rewritten as this. The x minus 5 can cancel, so that means we're left with the limit as x approaches 5 of x squared plus 5x plus 25. And so now we can just plug it in. So we get 5 squared, which is 25, plus 25 plus 25, 75. There's our final answer. Alright, well, I think that's good enough for today, so hopefully this was helpful. Just keep your eye out, go ahead and subscribe to get more notifications, and click that little bell icon and you'll get notifications when I release more videos. And thanks for watching, and I'll see you next time.